Hello everyone. This session is about network slicing concept in 5G. I am Ashok Kumar. Introduction to network slicing. So let us look at what is network slicing. So network slicing is creating multiple logical network over same physical infrastructure. What does it mean is that I can have physical infrastructure like servers, compute, memory, network, and I would kind of virtualize that environment. And onto the top of virtualized environment, I have many network functions related to 5G, and those are logically partitioned. So I have multiple logical network on same physical infrastructure. So every such logical network or every such slice is for a specific requirement or specific service. For example, if I'm offering a IoT kind of a service, so I can have a slice, network slice, which will be for IoT service, particular IoT service. Or if suppose I'm offering a smart meter service, so my network slice or that logical partitioned network will be for that particular smart meter service. So every such service will require certain specific quality of service. So there will be a requirement of a specific quality of service for that particular slice. And when we say network slice, it is end to end. When we say end to end, that means starting from your radio access network, in our case maybe G node B, then you have backhaul, that may be uh, uh, front haul, mid haul, backhaul, and then it comes to core, and then you have the service itself, the server or application server itself. So the network slicing is creation of such logical network which is end to end along with application. And these separation or logical separation of the slices are such that they will not affect each other. It means whatever compute or resources has been allocated to one slice, it will not snatch more than that from say other slides. So unless you allocate more resources. Similarly, if there is some security requirement in one slice that is limited to that, right? You can build a particular slice having certain level of security. Or suppose if there is some security breach happening in one slice, it should not affect the other slices. So that is logical separation in a way that they are not affecting each other. So let us look at a network slice example. So in a 5G network, we have RAN, radio access network. We have 5G core, and of course there will be a backhaul connecting a radio access network to 5G core. Now on this particular infrastructure of 5G RAN and 5G core, including the backhaul, we can create network slice. In this example, this is an autonomous car. So for autonomous car, which require a specific quality of service like a latency requirement or reliability requirement would be very, very important. In addition, for infotainment system or for cameras, etc., requirement of certain bandwidth or enhanced mobile broadband feature would also be required. So having all those required quality of service in particular slice, that is V2X network slice, will be a requirement. So, and it will connect to V2X service. Similarly, the network within the same physical infrastructure of the 5G network, I can have another slice which we may call it as a smartphone service slice, smartphone network slice, and we may also have, say, smart meter network slice. So I can have n number of network slices offering different service and also different quality of service requirement will be supported in that particular slice. Now let us look at how network slice has actually evolved over a period of time and where we are as of now. Let us first look at ITU framework for network slice. So ITU-T, that is telecommunications sector of ITU, deals with this particular topic or subject. So ITU-T had issued a document called Y.3112 in December 2018. So this is framework for support of network slices for IMT 2020 network. So IMT 2020 is the name given for 5G by ITU. So if you read this particular document, so it has given the concept of network slicing. So as we know that 3GPP had defined three broad usage scenarios of 5G. Those were enhanced mobile broadband, EMBB, massive machine type communication, and URLLC, ultra reliable low latency communication. So in this example given in that document, so that example gives that within the 5G network end to end, I can have a slice which can be called enhanced mobile broadband slice. The second slice can be massive machine type communication slice. And the third can be URLLC or ultra reliable low latency communication slice within the IMT 2020 or 5G network. EMBB slice may be for normal voice, internet, AR, VR, etc. MMTC may be for logistics, agriculture, and URLLC may be for a automobile factory kind of. So same document also gives how it can be implemented. So in this particular picture, what they are trying to show is that in every slice, suppose EMBB slice instance, there will be service label network functions. Network functions required to support EMBB slice would be inside that slice. Similarly, URLLC slice instance will have service level network functions which are required to support URLLC. That may be, say, SMF, PCF, and so on. But there can be some network function which is common to both the slices. So those network function may be called as UV label network functions, right? So the UV can actually connect to multiple slices even simultaneously. So that's why there will be certain network function which is at UV label. That means that network function is common to one or more than one slices. There is another use case example given in that document. In this example, what is being shown here is that yes, we have three slices: EMBB slice, MMTC slice, and URLLC slice within the IMT 2020 network. But suppose there is a car, so and suppose it's a self-driving car, and also the automobile company is offering certain more services to this car. So this car connects to the URLLC slice, which gets connected to the automobile factory. The service or server is here, application or service is here onto the automobile factory. But since this car would also have infotainment system or maybe certain cameras inside it, so it has to connect to EMBB slice. So that shows that one user, in this case car, is getting connected to more than one slice. So that kind of a concept. In another example, where it is shown that there are two URLLC slice, one for A motor, maybe a company manufacturing a car, B motor, the another company manufacturing the car. So they are offering certain services to the cars which are manufactured by them. So you have automobile A motor service, automobile B motor service, and then you have a common EMBB slice. So both cars, both brand of car, the services are being provided by those, say, OEMs or manufacturer. In addition, these cars are also connecting to the common EMBB slice. So a very good example or the concept given by ITU. Now let us look at how network slicing has evolved in 3GPP, third generation partnership project. So 3GPP is a sort of de facto SDO, standard developing organizations, whose content technologies are approved by ITU as 5G or earlier as 4G. So let us have a look at it. So in release 14, so 3GPP has release versions. For example, the 4G started with release 8, 5G started with release 15. So in release 14 itself, they released a TR 22.891. So this was technical specification group services and system aspects. That is a group which works on this. So they have given a feasibility study on new services and markets technology enablers, stage 1. So in this document itself, which was released in 2016 itself, what they said, they give two kind of requirement for a network slice. One is the service requirement, other is the operational requirement. Based on these requirements itself, now further specifications have evolved. So let us have look at the service requirements and operational requirements. Okay, let us first look at service requirement of network slicing. So what are those service requirement? The first service requirement is that operators should be able to compose network slices from the common infrastructure of the network which they may have. So that is first service requirement. The second requirement is that creation of network slices should be possible in a dynamic way. Dynamically, operators should be able to create network slice. That means with certain command, you'll be able to create a certain command or configuration, you'll be able to create a network slice. That's a requirement I'm talking about. The OEM have to build such uh, possibilities or features. The third requirement is that certain terminals or subscribers, they should be able to get associated with a particular network slice. That means if a user equipment has subscribed a particular slice or service, it should be able to associate with that particular network slice. And it should enable you to obtain service from a specific network slice. So suppose a particular service is being offered where slice A is being used, so UE should be able to get the service. Maybe based on subscription, I take subscription for a service and then I am allowed to use that. So these were service requirements of network slicing defined in that particular TR. And please note, it was defined in year 2016 itself. Now, what is the requirement for operational requirements? Operational requirements can be create and manage network slices. So operators should be able to create and also manage the network slices. And operators should be able to create different network slices in parallel with isolation. That means the network slices should be isolated from each other and they should work in parallel. The third operational requirement is that system must have capability so that the specific security assurance requirement or requirements are provided within the slice, within that particular slice. So that means if there is a specific requirement of security for a particular service, I should be able to implement that in that slice itself. There should not be requirement that I have to implement that for the entire network. So slice specific service assurance requirement I should be able to meet. The next requirement is about isolation in terms of security. So in case there is a cyber attack on a particular slice, other slices should not be affected. So capability to provide a level of isolation between the network slices which confines a potential cyber attack to a single network slice. Operator shall be able to authorize third parties to create, manage a network slice configuration. So for example, if a operator created a network slice and given it to a virtual operator. So now virtual operator should be able to manage that slice, whatever configurations are required within that slice, the virtual operator should be able to manage. So operators shall be able to authorize third parties to create and manage a network slice configuration. The next requirement is about the elasticity of the network in terms of capacity with no impact on the services of this slice or other slice. So that means if I have to increase resources for one slice, it should not affect others which are allocated certain resources. Now there is a requirement about changing the network slice. Suppose a new network slice is to be added, an existing slice is to be removed or updated. So the 3GPP system shall be able to change the slices with minimal impact on ongoing customers or subscribers services. The next requirement is about creating or doing resource management, which is end-to-end, to support end-to-end resource management either in the RAN side or core network side for a particular network slice. What all resources would be part of a network slice, I should be able to manage. That's the requirement. Now let us look at release-wise evolution of network slices As I said that 5G started with release 15. So as of now, we have release 15, release 16 and release 17 as far as standards are concerned. The commercial products are becoming available up to release 16. So let us have look at basic features which came on a particular release. Okay, so let us look at release 15 first. So the foundation of network slicing came in release 15 itself. The first release of 5G itself was having this network slicing concept. In release 16, which came around 2020, certain enhancement came in the network slice. In addition, slice level authentication feature also came during release 16. That means if a particular network slice requires a second layer of authentication related to that service, so that has been made kind of a native, or the network itself is supporting that. In release 17, again certain enhancement happened. In addition, we had concept of RAN slicing. This may be a misleading topic, basically support of network slice onto the RAN and admission control. Admission control means if in a network slice, uh, admission control will be possible in terms of how many numbers of customers can actually be supported, or how many PDU sessions would be possible within that particular network slice. So admission control, if that limit is full, then no new UV would be uh, given access to that network slice, or no more PDU session would be created. So before we go through other concepts of network slicing, we need to understand the basic concept of 5G architecture, PDU session, protocol data unit session, and quality of service. That will help us understand better the concept of network slicing. So let us go through it. So let us first look at what is PDU sessions and quality of service flow. So this is our 5G network, or we also call it service based architecture, because each network function here exposes certain service which other network functions can consume. And this 5G network is divided into user plane. That means all the user data flows through this, from UV to RAN to UPF to the particular data network. So this is user plane. This is different from early technology, because earlier same network function used to be common for control plane and user plane. So this is user plane, and upper part is the control plane. When I'm talking about PDU session, it has to be in the user plane, the user data flow where happens. So this particular pipe you see is kind of a PDU session. It's nothing but series of connection from user equipment to RAN to UPF to the data network itself. So end-to-end connection, which is called PDU session. And on this only the user data, actual user data flows, and all the network function in the control plane, they actually support, so that this PDU session is continued even if a customer is moving from one place to other place. So let us now look at a PDU session in slightly detail. So what happens that when a user equipment, in our case in 5G, user equipment can be a mobile, can be a car, can be any object or any machine. So that's why it's a user equipment. It can be any type of device. So when it suppose I mean it becomes on from off stage, it is switched on, so it registers onto the 5G network. So it follows certain procedure and registers into the 5G network, and at that point of time a default PDU session is created. So within the pipe of PDU session, one default, let us assume that this particular blue color uh, a PDU session is created, and within PDU session a quality of service flow is added. QS flow is added. So this is a PDU session, and inside the PDU session at the time of registration a default QS flow is added. Now if that UV want to use certain service which may have certain different quality of service, for each of such services which have different quality of service, a separate QS flow will be added. A separate QS flow will be added. So in this example, so many QS flows are added into the same PDU session, and each QS flow will have an ID and its characteristics, that what is the guaranteed bit rate, what is the latency supported, what is the bit error rate, and so on. So this is concept of PDU session and quality of service flow. Now suppose there is one network slice or two network slice. In this example we are showing end to end two slices, slice 1 and slice 2. In slice 1 there are two quality of service, QS flow A and this slightly darker color which you see here is QS flow B. So that means one network slice may support one or more than one quality of service flow. In slice 2, it is shown that it is supporting QS flow C. So maybe, so that means one slice can either have one QS flow or it can have more than one QS flow. So of course within PDU session there can be many PDU session created for different users within the slice, and within that PDU session there can be one QS flow or more than one QS flow. Now let us look at what are different network functions in 5G which will support network slice. Let us look at this picture. So earlier also we saw the 5G network architecture. So here what we are trying to show is the network functions which are specific to network slice concept. The NSSF, this is network slice selection function. It's written here. Network slice selection function. We'll talk about these later, but let us first understand. And this came during release 15 itself. As I said that release 15 was some sort of foundation for network slice. In release 16, certain enhancement, but one more network function was added. This is NSSAAF, that is network slice specific authorization and authentication function. That means I can have a second level of authentication within the network slice for that particular service, and for that this network function will come handy. Further in release 17, one more network function was added which is called NSACF. So this is network slice admission control function. This one, network slice admission control function. So we have NSSF, network slice selection function. Then we have NSSAAF, it's here. This is network slice specific authorization and authentication function. Then we have NSAF, which is network slice admission control function. Okay, so let us start from network slice selection function, that is NSSF. So what it does, uh, let us look at that. So as I said that every network function in 5G network being a service-based architecture will expose certain service, right? So NSSF is will also be offering certain service. And who is the consumer of that service? The consumer can be AMF, access and mobility function, or network slice selection function of other operator, other PLMN per se, that is required when user is roaming into other network. What are those services being offered by NSSF? The first service will be consumed by AMF and other operator or visited network slice selection function. So this service enables network slice selection in both the serving PLMN and HPLMN. So for a particular user, which slice is to be offered, whether the user is authorized to access that slice or not. So basically, NSSF provides that information to AMF and visited network slice selection function. The second service which it offers is about availability. For example, a particular network slice is offered on a TA basis. TA is tracking area. So the entire coverage of 5G is divided into tracking area that may consist of one or more cells, right? So in a particular tracking area, maybe slice 1, 2 and 3 is supported, 4 is not supported, and so on. It is also possible that a particular AMF supports certain slices and other slices are supported by some other AMF. So this information is available with an SSF. So for example, now this particular service, let us look at. So whether a particular network slice, which is also like network slice selection assistance information, so NSSAI, that's the name, which identify a particular network slice. So whether that is available on a TA or not. So the AMF would subscribe to this particular service so that the particular slice or S-NSSAI supports on per TA basis on the NSSF and to subscribe and notify any change in the status on a per TA basis. So AMF will subscribe to this service, and if there is any change, the AMF will be notified about that. And why it is important? Let us understand that suppose a UE is connected to a particular AMF when it trying to access a service. In core network, it first talks to AMF. And if that AMF is not supporting a particular network slice, so it has to transfer the call to the AMF which is handling that. So there also it must have knowledge about that, right? So that is coming from this service. So in summary, AMF and NSSF in other PLMN take help of NSSF to find allowed and configure network slices for a UE. So that is the selection part. If current AMF do not serve a requested slice, it asks NSSF for appropriate AMF handling that slice on a per TA basis, right? And it also kind of subscribe to a service that if there is any change, it should tell the AMF. Now let us look at network slice specific authentication and authorization network function, which came in release 16. So this is for what? This is for facilitating slice specific authentication. And who is the consumer of this service? The AMF is the consumer of this service, right? It also enables re-authentication or revocation of a particular authentication which has happened earlier. So that means the first service is authenticate, right? So this NSSAAF will perform slice specific authentication and authorization for a given UV. So there will be a request from AMF of that authentication along with the required parameter, and this particular network function will respond either authenticated or rejected. The two other services are some sort of callback. That means this NSSAAF will call back AMF on what condition? Suppose it is decided that UV has to be re-authenticated. So it will call back AMF and send a notification that re-authentication is required for a given UV. So AMF can start a re-authentication process using this service. Or it may so happen that the authorization or authentication given to a UV has to be revoked in a particular slice. On that case also, it will call back to AMF and say that the authorization or authentication given to a UV has been withdrawn or revocation has happened. So AMF will immediately close the call which UV is having on that particular slice. So this is about network slice specific authentication and authorization function. Now let us look at this particular picture. So basically this particular feature would be available to only those UV, that means slice specific authentication, which are capable of it. So basically UV had certain capability which is kind of informed to AMF into the registration request itself. UV tells its capability, right? There is a UV capability parameter, and it will say that okay, yes, NSSAA slice specific authentication is supported by me, then only the UV would be able to access the slices where this authentication is enabled. Suppose UV is not capable. In that case, UV can be stopped. Yes, you cannot. The particular UV cannot access a particular slice because it is not enabled for slice specific authentication. Now the next network function is network slice admission control function. So who is the consumer? So consumer is AMF, SMF, NEF and AF. AF is application function, network exposure function, session management function, access and mobility function. So basically on a particular slice, how many UV can latch? How many user equipment can be connected? or total how many PDU session can be created on that particular slice. So this can be configured or decided. So upon reaching that stage in terms of number of UV or number of PDU sessions, the new UV would not be admitted into that slice, or new PDU session would not be created. So let us look at the two services which this network function will be giving. So this service will be consumed by AMF and SMF is about allow network function service consumer, that is AMF or SMF, to request NSACF, network slice admission control function, to perform per slice admission control for the number of UVs or PDU session. That means AMF is requesting this NSACF that please control that total numbers of UV into this network, this slice, or total number of PDU session, whichever comes, is not exceeded a particular value or number. So that is one service which controls the admissions. The other service about certain events. So this NSACF provides certain count of number of user equipment which are connected to a slice, or number of PDU sessions which are already established onto that slice. So this is kind of an event or notification which is sent to NEF and AF if they have subscribed to this particular notification. So that, I mean, they take a decision, because all application functions may belong to certain network slice, or maybe the third party application functions are getting connected through NEF. So knowledge of number of PDU sessions and number of UV on a particular slice is important for these network elements. Now let us look at how a particular slice is identified and selected. Identification and selection of a network slice. Okay, so let us understand what is S-NSSAI. So this is, S is single, network slice selection assistance information. So basically this identify a particular slice. So it is some sort of a number, maybe slice 1, slice 2, we can say in a layman language. It has got two parts. The first part is SST, slice or service type. For example, EMBB is one service, so there can be. So this is an 8-bit information. And then you have a sliced differentiator, that how you can define a particular slice. For example, EMBB slice. There is one slice which is for EMBB. There can be more than one EMBB slice in a network. How do you differentiate? With SD values. So this can have some value, this can have some other value. In 3GPP standard, they have defined only standard value of S-NSSAI. They have defined a standard value of, so what are those standard value? So they have defined a particular SST values and what kind of service it is. In that standard NSSAI, we don't have SD. So in case SDs are required, that is done at the operator level. 3GPP has not defined. And as I said that SD is to differentiate same type of slices for different set of users in case a particular operator want to do that. Example can be that certain set of UV is accessing this network slice. Set of UVs is suppose there is a EMBB, and certain other set of UVs would be accessing the other EMBB slice. Okay, so this table gives the standard value of SST of the network slice. So SST value is 1, that means it is an EMBB slice, right? SST value 2 is for URLLC. SST value 3 is of massive IoT, 4 for V2X, or 5 for HMTC. HMTC is high performance machine type communications. So far, that is up to release 17, 3GPP has defined 5 types of slices. The rest of the values from 6 to 127 is reserved. Maybe in future releases that can be defined. And from 128 to 255, they can be operator specific network slices. Okay, so before going forward, let us understand certain definitions like what is default NSSAI, what is configured NSSAI. Whenever we say NSSAI, basically we refer to a list of network slices. So NSSAI is nothing but a list of S, that is single, and SAI, right? So what is configured NSSAI? So UV is provisioned with configured NSSAI for a PLMN. So it is a list of specific slices which is provisioned inside the UV, right? UV may store one configured NSSI, that is list of network slices it may have for every PLMN, and these network slices or S-NSSI, which is inside configured one, are actually subscribed by the UV, right? So as I said, it is per PLMN. So that means if suppose I'm in a area which is not my home network, so whatever list of slices it has corresponding to visited network will have mapping to some S-NSSI which it has subscribed of the home PLMN. I hope you understood. Then what is default configured NSSAI? What is the list of slices which is called default? So generally the default NSSAI will be for the HPLMN itself. So this provisioning happens for the PLMN UV belongs to. And this, the default one, would be common to multiple PLMN, right? This is important for roaming because these are the slices kind of supported in all the roaming partners. Now that's why it has been made default, right? So even if you are roaming, those kind of slices are available in the roaming partners also. That means, I mean, default configured NSSI is expected to have standard value of S-NSSI, meaning what? 3GPP defined slices, right? The last point is that suppose UV do not have configured an SSAI for some reason, so it can use the default one which it has from the HPLM. Then there is a concept of requested list of network slices and allowed list of network slices. So when UV registers onto the network, it requests for list of network slices, right? It says that please allow me this list of network slices. This is used by G node B or any other access network for that matter to select a particular access and mobility function onto the control plane side, because a particular slice may be supported by a particular AMF. So UV has to connect to that AMF. And whatever request it makes, the UV is requesting for a network slice or list of network slice, that can either be from configured or from the default list of slices. Then what is allowed list of network slices? The allowed is that once registration is successful, the network informs to the UV that these are network slices which are allowed to you on that particular area, or so that depends upon what subscription you have, in which tier you are. So those particular network slices are only allowed. So those are called allowed list of network slices. There can also be rejected list of network slices. So AMF also provides to the UV one or more rejected network slice with cause and also the validity of rejection. So a rejected particular slice maybe for the entire PLMN or maybe from the current registration area where the UV is. So UV is not expected to use these network slices as these are in the rejected list. Now let us look at different network functions which may be inside a slice or outside a slice. In this example, we are showing three slices. Slice 1, so this particular box, slice 2, this box, and then slice 3. What you see that inside the network slice, there are certain network functions. Here I have user plane function, policy control function, session management function inside this slide. Slice 2 is also having same network function. There are network functions which is common to these two slices. They are PCF, network repository function, access and mobility function. Right? That means there may be a certain network function which is common to more than one slice. Now let us look at the third network slice. In case of a third network slice, this NRF AMF is also part of the slice itself. Right? On top of that, the two network function, network slice selection function and network repository functions, are common to the three slices, because it is very important to select a particular slice, so it has to be beyond the slices. And NRF also have addresses or FQDN of all other network function, so that is also required outside. So these two network function is common to all the three slices. So that means there will be certain network function which are dedicated to a slice. There may be network function common to more than one slice, and there may be network function which is common to all the slices. The other aspect here we can see that a network slice can connect to one data network or more than one data network. But we also see that one data network is connected to more than one slices. That is also a possibility. Now let us look at network slice and PDU sessions, those user plane connectivity. So we have same picture. We have user equipment, we have radio access network, and then we have individual slices. So this user equipment uh, has a PDU session. This particular line, please assume that as a PDU session or a pipe where user data is flowing. So as we know that user data flows through UPF. So basically UV to RAN to UPF and then to the data network. The same UV may have another PDU session through the slice number 2. So here also RAN, UV to RAN to the UPF of slice 2 and to the data network 2. So this UV is kind of using two services from different slice. So UV can connect up to 8 slices simultaneously. This is given in a standard. When, this is very important, when UV is connecting to more than one slice, there has to be the same AMF, common AMF for the UV. Single AMF will serve the UV for both the slices. And there will be only one PDU session in one slice for that UV. Now let me reframe it, sorry. That suppose there is one PDU session, it will be inside only one slice. So one PDU session will not belong to two slices. There is limit of number of slices one user equipment can access to simultaneously, and there is also a limit on number of PDU session one user equipment can access to simultaneously. So it is 8 number of slices, so user can access maximum of 8 number of slices simultaneously, right? And user can access maximum of 15 number of PDU sessions simultaneously. These PDU sessions may be across different slices. In this picture you see that in slice 1 there is one PDU session, in slice 2 there are two PDU sessions for one user I am talking about. So that is limited to a total of 15 number of PDU session for an UV simultaneous access. There is also a concept of network slice simultaneous registration group. So in fact, when UV registers onto the network, it registers to different network slices, right? So there is a concept of that user equipment can simultaneously register to a set of network slices, or that we call it network slice simultaneous registration group, NSSRG. So what is NSSRG? So basically a UV subscription, whatever UV subscribe, may contain network slice simultaneous registration group information. And what it will contain? It will contain a list of network slices. And UV can register itself to all the network slices in that group simultaneously. During the UV registration, UV can register itself to all the network slices in that group, in that NSSRG. So where this information will be available? So either UV can be provisioned, UV itself will have an SSRG information, or during registration AMF is passing on that information to the user equipment. So basically in this example, let us see that UV can register to more than one network slices, that is single NSSAI, at the same time only if these slices have the same NSSG number. For example, let's take an example. UV is allowed these slices, slice 1, 2, 3, 4. Let us assume, right? That means UV has subscribed to. Now, UV will also have information about NSSRG. Either it is provisioned into the UV or AMF provides that. So suppose this particular picture that NSSRG2, let's see this, NSSRG2 have slice 1, also have slice 2. Similarly, NSSRG4 have slice 1 and so on. So there will be, so these two, whatever you see is common for say slice 1 and 2 and also 3. So that means UV can simultaneously register for slice 1 and 2 and 3 all because it belongs to the same group 2. Okay. So that is the concept that if a particular slice is part of a group, particular number of slices are part of a group and UV is allowed on those slices, so it can register to those slices simultaneously. So let us summarize. So UV may register to more than one slices simultaneously. Network slice simultaneous group, simultaneous registration group, NSSRG. This is an information to enable control of which network slices that can be registered simultaneously. That means it contains the list of slices for a particular UV and that you can simultaneously register to it. So subscription information for UV may include each S-NSSAI, that is network slice, simultaneous registration group information, constraining which S-NSSAI can be simultaneously provided to the UV in the allowed NSSAI. Out of the allowed network slices, which on it can simultaneously register is limited by this particular group. And this particular aspect is an UV capability. That means UV need to support this feature. Then only this can be enabled. Otherwise, UV may not be able to register to multiple slices at a time. One more feature has been added, which is support of data rate limitation per network slice for an UV. So what is this? So basically, if you look at quality of service concept in 5G, so for different type of quality of service, suppose there is a guaranteed bit rate or non-guaranteed bit rate, there is a concept of UV amber. I mean, what is the aggregated maximum bit rate at the UV level which can be allowed, or a session number. So within a PDU session, how much aggregated maximum bit rate can be allowed. So that feature was there in release 15 and all. So now in further releases, there is a concept of limiting the data rate or the maximum bit rate onto a slice for an UV. So suppose there is a slice, how much maximum data rate one UV can be allowed. So you may have one PDU session or more than one PDU session onto that slice. So combinedly, how much data rate can be allowed onto that slice? So that is called data rate limitation of that network slice. So you have UV, you have a slice, you may have PDU session 1, a PDU session A, you may have PDU session B, you may have PDU session C. In each PDU session, some data rate is being allowed, some data rate for the UV is being allowed. Now, combinedly, if you add up these data rates, this should not exceed the UV slice number which is defined in the network, right? So there is a parameter of UV slice number. Within a slice, how much maximum bit rate which can be given to a particular user equipment. So this is called UV slice MBR. This was introduced in release 17. This is an optional parameter. This is an optional parameter. And then when UV subscribe, this is kind of a provision that what could be UV slice MBR for different slices. And this particular parameter is for 3GPP access. That means it will be in a RAN, that is Z node B or new radio kind of a radio access network. It may not be applicable in a non 3GPP access. And how this is provided? So AMF provides this information to RAN along with allowed set of network slices, and monitoring of it is done by PCF, policy control function. Now let us go through support of network slice in RAN, or in other terminology we also call it RAN slicing. So how resources are allocated within the RAN, radio access network, to make slices work. So basically the concept is that you have user equipment, you have radio access network. That radio access network, or for that matter cell, particular cell, so it may have multiple cell. So maybe frequency 1 is there in cell 1, frequency 2 is in cell 2. So it is defined in the network that, okay, this frequency, this cell will support slice 1, which is say EMBB slice. Frequency 2, cell 2 will support slice 1, that is EMBB, and also slice 2, which is URLLC slice. So this particular cell of frequency supporting EMBB slice and also URLLC slice. So this way you are able to distribute the resources, that is the radio resources, for different network slices. And this concept is used for slice based cell reselection. What is it? So suppose one mobile user equipment is moving from one area and going to other area, right? So it suppose moving from cell 1 to cell 2. Okay, so when it moves from one cell to other cell, so earlier the best cell was selected, in the sense that whatever best cell is available, that is selected. But with this concept, the support of slices will also determine whether the best cell will be selected or second best cell will be selected. So that means if a user is using slice 1 EMBB, it moves to slice 2, and slice 2 is, yes, supporting EMBB, so this handover would be possible. Suppose there is frequency 3, cell 3, where EMBB slice is not supported, whereas the signal strength is much better, the handover may not be allowed. It may be said that, okay, go to the second best because you have EMBB slice there. So slice based cell reselection concept comes into it. And the other thing is slice based RAS configuration. Random access configuration is also now slice based. That means during initial registration also, the support of slices has got impact onto the initial registration process, random access process, when it synchronizes in the uplink direction. Now to support this, there is a concept, we call it network slice AS group. AS here is access stratum. That means the radio part or access part. If it is radio, then the RAN part. So there is also onto the radio side, there is a group of network slices. They are grouped together. So for example, and these groups are defined on a tracking area basis. What is tracking area? So in any radio network, you'll have a cell 1, cell 2, cell 3, cell 4, cell 5, different towers, different cell. In one tower, you may have three sectors, and three sectors you can call cell 1, cell 2, and cell 3. Other tower, again, you'll have cells. So a cluster of cells is called tracking area. A cluster of cells, contiguous cluster, is called tracking area, right? So this NSAG is defined on a TA basis or tracking area basis. So for example, let us see this example, that in this tracking area, I have two NSAG, two AS groups, say group 1 and group 2, group 4. And let us assume that this group will support only say network slice 4, but this group is supporting network slice 1, 2 and 3, right? So now, while initial registration or cell reselection, this this affects the cell reselection and initial registration of the RAS, random access process. Now let us understand how different NSAG group and network slices are made available in different TAs. So the first concept is that one NSAG may be in more than one TA. So here this is TA1, tracking area 1, tracking area 2. In tracking area 1, NSAG group 1 is there and NSAG group 4 is there. In tracking area 2, NSAG 3 and NSAG 4 is there. So what we are trying to say that one NSAG, in this example say NSAG 4, is available in TA1 as well as TA2. So this is one concept. Second concept is one slice can be in more than one NSAG group but in different TA. Meaning, for example, this network slice 4 is in NSAG 1, right? This network slice 4 can be in other NSAG group but in other TA. So here if you see, it is also there in NSAG 3 in the network slice 4. Okay. Now let us look at configuring NSAG in the network or the UV. How UV or network will have the information about NSAG. So basically RAN, whenever radio access network is kind of configured for the first time. So you connect a ONM terminal and configure it that it will support which particular NSAG, right? So it's pre-configured. Which TA will support out this RAN may have multiple TA. So which TA will support which NSSG and which slices inside that. Now when it is switched on, so it sends, related information to AMF. During NG setup or RAN configuration update procedure, these are sent to AMF, right? So during the initial switch on of RAN, this information goes to AMF, or if it is say provision later on, then during the update procedure, RAN configuration update procedure, this NSSG information goes to AMF. And AMF will further provide this information to network slice selection function, right? So this is how these are configured. And how UE gets it? UE should also have information about NSAG. So during registration process, when registration accept message is coming to UE, it is getting the NSAG detail in that message. Or there is configuration update command from AMF. So configuration update command, AMF can give it to UE, and in that this NSSG information can be given to the user equipment. So now there is a limit of how many such. So that limit is 32. So UE can have a maximum information about 32 NSAG. Just look at this, how a group, this NSAG group will look like. So this is NSAG 7, group 7. So in this example, it will contain slice 4, slice 8 and slice 3. And this is available in tracking area 1, tracking area 4 and tracking area 8. Similarly, NSAG 8 is having slice 5, slice number 9 and slice number 7, and it is available in NSAG tracking area 1, tracking area 3 and tracking area 8. Let us look at few more examples of RAN slicing. So suppose there is a factory area where requirement of a slice which is URLLC is there. So there the radio access network, let us assume that you have frequency 1 cell 1 which is supporting EMBB slice, and then you have frequency 2 cell 2 which is supporting EMBB and URLLC. So operators can actually configure this way that in a factory area, whatever cells are there, their support of URLLC would be given. That means the slices supporting URLLC use cases can be made. This is another area, suppose railway station. So railway station, primarily the users of enhanced mobile broadband would be there. So here we can see that in both the frequencies and cells, we are supporting same slice one, which is EMBB. So according to the need, operators would be required to define that in which tracking area, which slices would be supported depending upon the specific use cases that may be required in that particular area. Now, whether network slice in 5G can be interworked with 4G or evolve packet system? So answer is yes to some extent. How it is done that in case of 4G or EPC, what they do is like, so suppose they want to build in a 4G, what you have a RAN, which is E node B, and then you have core, which we call it EPC, and then you have packet data network, PDN. This can be a service. So generally, operators, and even in the standard, there is a concept that suppose you want to support a specific service, for example, narrow band IoT. So for that, a new EPC is built for this. So that means, and the same E node B can route the traffic of NB IoT to this EPC. So that is a concept in 4G, later version of 4G. So that means, I mean, what I'm trying to say that EPC supports having multiple dedicated core network, we call it DCN, dedicated core network. This core network is for general use, and this core network is for NB IoT. So this is a kind of a slice at core level. So only the core is having different slices. Let me remove the ink. So in release 16 of 5G, mobility of 5G network slice and 4G EPC is supported. So all those corresponding, suppose corresponding to IoT slice in 4G or IoT DCN in 4G, there may be a slice in 5G. So if an user is moving from 5G to EPC or EPS or vice versa, that mobility would be possible in a corresponding slice. So in that case, I mean, when we are moving from 5G to 4G, that particular user equipment, so based on DCN ID, a particular MME is selected by the 5G network during the handover process. Now we have seen that a lot of stuff has come into the standard, but 3GPP has not defined a specific template for a particular slice. Template means, for example, if there is an EMBB slice, what should be guaranteed bitrate, what should be uh, uh, latency, what should be error rate. These parameters are not defined specific to a slice. This work is actually done by now GSMA. So GSMA has created network slice template so that operators can follow, and it will be very useful in the roaming scenario. That similar services are available across the different operators. So this is a standard picture or diagram or the concept which GSMA has given. So basically GST is generic network slice template, and then when you prepare, this is nest is network slice type. So how this network slice is prepared? So GST gives you the parameters, like GST provides only list of parameter. And what is nest? When you fill all those parameters of GST for a particular slice, it becomes nest. It becomes a kind of a template which can be applied onto a particular slice. So for example, so in the same document, they have given a nest parameter for high performance machine type communication. So we saw that one of the network slice type defined by 3GPP is this high performance machine type communication. So they have defined what should be the availability. So 99.99959. Device velocity they have defined as 0. They are not expecting those devices to be a mobile device. Those devices would be kind of a fixed device. They have also decided the density, that in 1 square kilometer maximum 1000 such user devices would be there. And mission critical support, yes, they are saying mission critical. So these are various data, and which kind of quality of service. So In 5G, the 5QI parameter defines uh, quality of service parameters, and they are numbered. So QS 5QI value 83 would be applied for such slices, this slices. One more example, let us take one more example. So this is Nest for massive IoT. So here availability is not a very critical requirement, so it is 99.939. Slice quality of service, that is 5QI values here 9. Density is very high, 100,000, 1 lakh. Density means per square kilometer how many such user equipment would be supported, and device velocity would be 2, right? 2 means like 2 kilometer per hour. I mean very slow moving devices. So it's a factory environment where we consider as slow moving objects is supported. So that's it in this particular course. Thank you.